Now, there are two equations you need to know. First, we have Q is equal to ml and Q is equal to mc delta T. Now, for the equation at the left, Q is equal to amount of heat energy absorbed or released and is measured in joules or calories. We know that 1 calories is equal to 4.184 joules. The calories is in small letter, so we know 1 calories that is in capital letter is equal to 1000 calories in small letter. Both joules and calories are used as unit of energy, but joules is usually more common. M is equal to mass and is measured in kilogram. L is equal to latent heat of fusion, which is LF, and latent heat of vaporization, which is what? LV. Now, this particular equation is usually used when there is a change in phase. Latent heat of fusion is the energy required for a solid to melt toward a liquid, while latent heat of vaporization, which is LV, is the amount of heat energy required for a liquid to vaporize to gas. Latent heat of fusion is positive when a solid turns to liquid and negative when a liquid turns to solid. Take for instance water. The latent heat of fusion of water, LF, is equal to 3.33 times 10 raised to power 5 joules per kilogram. So it takes 3.33 times 10 raised to power 5 joules of energy to melt 1 kilogram of ice to liquid water. While latent heat of vaporization is 22.6 times 10 raised to power 5, meaning it takes 22.6 times 10 raised to power 5 joules of energy to vaporize 1 kilogram of water. So you see, the latent heat of vaporization of water is higher than the latent heat of fusion of water. Now, for this other equation, Q is equal to mc delta T. This equation first is used when there is a change in temperature. So the parameters in this equation, Q is equal to the amount of heat energy, C is equal to specific heat capacity, delta T is change in temperature. Now, for the specific heat capacity C, let's say water. The specific heat capacity of water, we will use CH, is equal to 4186 joules per kilogram per Celsius. What that means is that if you have 1 kg of water, it takes 4186 joules of energy to rise the temperature by only 1 degree Celsius. Therefore, a substance with a very high specific heat capacity can store a lot of energy without changing the temperature much. A good example is water. While substance with low heat capacity, for example metal, can change temperature by just adding a small amount of heat. Let's take some few examples. The question says, how much energy is required to melt 450 grams of ice? Now, let's start by saying solution. If you look at the question carefully, there is a change in phase. There is not change in temperature, but there's a change in phase. So since there's a change in phase, we'll use latent heat of fusion because we are melting ice. So solid is being melted toward liquid. So we use latent heat of fusion. And therefore, the equation we use will be Q is equal to mf. Since the value of LF, which is our latent heat of fusion, is in joules per kilogram, let's convert the mass of the ice from grams to what? Kilogram. So we know the mass of the ice, M, is equal to 450 grams. To convert this to kilogram, we multiply. So we know that 1 kilogram is equivalent to 1000 grams. Now the grams will cancel. So what we'll have now will be what? 450 times 1 divided by 1000, and what we'll get to be 0.45 kilogram. So we say Q now is equal to the mass, which is 0.45 kilogram, multiplied by latent heat of fusion 3.33 multiplied by 10 raised to power 5 joules divided by kilogram. So the kilogram will cancel. So what will be left with now is going to be 0.45 multiplied by 3.33 times 10 raised to power 5. And what we'll have as our final answer is going to be 149,850 joules. We can literally convert this to kilojoule by dividing our answer with 1000. So what we'll get will be 149.85 kilojoules. Let's take another example. So the question says, how much heat is required to raise the temperature of 0.5 kilogram of water from 20 degrees Celsius to 55 degrees Celsius? Solution. First, we'll look at the question in context. It says how much energy required to raise the temperature from 20 degrees to 55 degrees. So what that means is that there's a temperature change. So therefore, we're going to use this equation, right? MC delta T. Now, first of all, let's look for delta T. We're going to minus the initial temperature from the final temperature. So our final temperature is 55 degrees Celsius minus 20 degrees Celsius. So what we'll have is 35 degrees Celsius. And we know our mass to be what? 0.15 kilogram. So therefore, Q now, which is the amount of heat, is equals to the mass 0.15 kilogram multiplied by specific heat capacity of water, which is 4186 joules per kilogram per Celsius, multiplied by change in temperature, which is what? 35 degrees Celsius. Now we know degrees Celsius cancel degrees Celsius, kilogram cancel kilogram. Our final answer is going to be 0.15 multiplied by 4186 multiplied by 35, which is going to be equals to 21,976.5 joules.